Hi, my name is Vahan Davoudian. I'm a physics experimentalist for 30 years, and today our topic is Doppler effect. I've been doing this for 30 years. I'm a physics experimentalist, and most of the time I have replicated most scientists' experiment as much as I could if I had the material and everything else. And my inspiration came from nature, animals, insect, and the sports. And in fact, I just wanted to thank also YouTube for this wonderful opportunity they created so we can upload our videos, some other people can upload their videos, so you don't have to be a scientist. As long as you have something legitimate, you can put it on online so people can watch it. And in fact, I'm comparing YouTube like a huge network or university so everyone can put their videos and then they can exchange views and learn from one another. And I also like to thank so many viewers in science and physics. They emailed me, they love these ideas, and I used to post every month, but now I decided to do every 2 weeks, which I think 1 month is a long time. So from now on, I decided to do every 2 weeks, and I'm hoping by next 2 weeks I will have like electromagnetic wave or laser or color perception or optical fibers. So every 2 weeks I will do one. And today our topic is Doppler effect. This is amazing. This phenomenon is so important in our life, and it improved our life a lot. I will explain step by step, and then you can see. So Doppler effect by Vahan Davoudian, physics experimentalist, and this is my email, vahandavoudian@aol.com. Before I explain about this, I have to post my picture, which I did it for Doppler effect, and then you can see how easy it is to understand what do we mean by Doppler effect. And most of the time my physics experiments are unique because I have never seen in any books or anything like this before. Like this one, for instance, this is the best way you can explain electromagnetic wave or sound waves. And you can see this is the ambulance, and then instead of wave, I used spring. So what it is, for a student or the physics lovers, is easy to understand. So every time the ambulance is going, well, of course, the observer is here, and the observer is standing still. And he or she doesn't have to move. And imagine when this car is coming toward you, and then the pitches are so high. So in other words, it's high frequency. As it recedes, the pitches are getting less and less. But you can see here what it is, how easy it is to understand. See, this side is stretched, and the other side is compressed or squeezed. So how easy it is to understand. That can be for sound wave, that can be for electromagnetic wave, and everything else. But in fact, this Doppler effect is so important in our life because I have to give you the history a little bit, and then after that we will explain one by one. So one of the great consequences of this Doppler effect was that they came up with the red shift and the blue shift, and what it is, that can determine the galaxies, nebulas, or even outside like Milky Way, that this galaxy is moving away or is coming toward us. And in fact, Edwin Hubble I have to explain this later. But you can see how easy it is to understand the Doppler effect. This is another car. See, it's compressing on one side and then stretching on the other side. So what it is, here the pitch is so high, here is pitch is less. It doesn't have to be for the ambulance. Sometimes I watch the airplanes, especially the propeller ones, they're flying low, so you can see when they're coming close to you, you can see the high pitch, and then after it's receding, it's going to be a low pitch. So let me now go back, and then I can explain what it is for the Doppler effect. Well, of course, I have another one. This is another way you can see it. Instead of using that kind of a spring, I can use this spring. See what it is? This side is compressed and this side is stretched. See what it is? It's exactly like, the sound wave is going around everywhere, see, like that. I hope you can see this. So the whole idea started with a physicist. His name was Christian Doppler. He was from Austria. He used to live in Vienna. And then one day, he was great physicist. He was having lunch outside. And then what happened, he saw a double-decker car came in. I mean, the first deck was empty, and then there were a bunch of, musicians playing music. And then he was having lunch. He noticed something strange. He noticed that, so hot over here. It's summertime. He noticed that, those musicians, when they came closer to him, he was having lunch outside, the sound was different. When they were going away, sound was different. And immediately he concluded that, it has to do with the low frequency and high frequency, or as they call it, pitch. So imagine when the car coming toward you and then you're standing still and you're the observer, and the pitch or the frequency is getting compressed. But when it's going away, so it's just stretching toward you. But when it's going away, it's getting compressed. So that's exactly what happened to Mr. Doppler. And then he came up with this idea. Let me read this for you. Discovered by Austrian physicist Christian Doppler in 1842, a common example of Doppler shift is the change of pitch. Change of pitch means frequency. Pitch is the same way. Heard when the vehicle sounding a horn approaches and recedes from an observer. And this is the observer I showed you a few minutes ago. And imagine, always in laws of physics, especially in Doppler effect, has to do with the electromagnetic and the sound wave. Stretching is exactly proportional to shrinking. So let me get another poster so you can see. I will explain one by one exactly what happened. Okay. One of the greatest advantage of the Doppler effect is this is amazing phenomenon. The reason why this can work with both sound waves and the electromagnetic wave. It's amazing because this discovery was breakthrough in science, and then it changed everything. And these are the sound wave. Well, of course, this is one of those. Then you can see this part is called rarefaction, and then this is like a compression. See, the waves or pitches are different, and here is a stretch, here is not the same way. So if you compare it with this is called longitudinal waves, and the electromagnetic waves are called, like transverse. And then you can see this is also can be, like compressed, or can be stretched, can be like squeezed. So, and then if I put this drawing on the table, from my perspective, sound waves move from left to right, transverse wave up and down. And you can see it's exactly like alternating current. It's going up and down, up and down. So this was the analogy. Well, of course, this is another one for the electromagnetic wave. Let me post this so you can see it. And in fact, I have to explain something important. Sound waves and the electromagnetic waves, even though sound cannot, travel in vacuum, but the electromagnetic can, because they have so many things in common. Like sound wave and the, electromagnetic wave, they can be diffracted, they can be like there will be, diffraction, there will be like a reflection, also, everything they have in common. So you can see here is the electromagnetic wave. One side is stretching, but it's exactly proportional to the, bunching up or, squeezing. It's exactly the same thing. I have another one here. You can see this here. This car is approaching this observer, which is standing still. See, they're a little bit, compressed, but when they go away, they're stretched. So they compress toward you, but when they go away, it's just stretched. And if you remember a few minutes ago, I said the most important consequences of this Doppler effect was red shift and the blue shift. Let me post this up. You can see this is amazing phenomenon. I will explain to you. So you can see exactly what do we mean by red shift and the blue shift. Well, of course, I have to give you a history a little bit. In fact, Doppler effect was in 1842, but another genius came. His name was Edwin Hubble, and Edwin Hubble was amazing astronomer, and then he changed our understanding like Albert Einstein. He was in Los Angeles, and then that was called Hooker telescope, and it was 100 inches. Imagine, it's almost 2.5 meters across. So in astronomy overall, in physics astronomy, anytime you have a huge lens, you get more light in. It's just obvious. I mean, you don't have to be a scientist to figure it out. So 100 inches exactly, 254 centimeters, or I would say 2.5 meters. So Edwin Hubble, was so good. His precision was beyond my comprehension how good he was. He realized what the scientists and astronomers said before him. Most nebulas, most galaxies were outside the Milky Way. What we see on the Milky Way probably is like more than 20, 30, or 50 billion stars. But unfortunately, we had no idea that was something beyond that galaxy. So what Mr. Edwin Hubble did, he realized all those we see before, the universe is much, much larger, probably billion times larger what they thought before, and then he came up with this idea with the red shift and the blue shift. So what it means that you cannot measure anything when it goes like a Milky Way and the beyond Milky Way nebulas, stars, because of the light year. They are like 20, 30 billions light year away from us. The only way they could tell, this was called red shift and the blue shift. Well, of course, this is his picture. His name was Louis de Broglie. He got Nobel Prize in Physics. He also analyzed the light, and he came up with this idea that red shift, blue shift. And then you can see here, we have like observer here. This one is blue shift, and you can see the waves are kind of, squeezed. So, but here they're stretched. So stretch here, and here the shrinking here. And this is the only way they could tell that, when this spectrum from that nebula, when the spectrum from that, galaxy is showing the red shift, or in other words, it's coming toward us, but most of the time it was going away from us. It was called red shift, which was stretching from us. So Edwin Hubble concluded that, the universe is much bigger, and then it's expanding. And that was great, breakthrough in science. And then people realized that he was right. And nowadays, this is used in astronomy, blue shift, red shift, a lot. It does everything almost. So I did explain about Edwin Hubble. Let me see if I missed anything here. I can explain again. And Edwin Hubble also discovered something amazing. He said those galaxies which are farther away from us, let me see, I can show you in another picture. Farther away from us, they are receding much faster. They are accelerating much faster. But those are closest, they're not accelerating that fast. And that became a law in astronomy that, Mr. Hubble did it. I can show you here what I mean by that. Let me post this up. You can see exactly what do they mean by, Okay, let me put this up. You can see. So this is another explanation for redshift, blue shift. See this spectrum is for the distant galaxy. You can see the shift is much more. See, these are the spectrum, and when it goes to the one nearby is shiftless. But this one explains much better. So you can see the shift, how they're shifted is toward the red spectrum. This one is less, this one is much less. So this was another way they could tell that, when the stars or any, astronomical bodies are outside even, or, solar system, they are going away. And this is another one, it's an exoplanet, and I have no idea what this star is, but see, this part is a red shift and this part is a blue shift. I have to read this for you guys so you can tell. Let me take this off so it won't be a problem to see this. Okay. Okay. This is the red shift and the blue shift. I have to read this for you. Red shift, blue shift, the nature of sound, red shift, relative increase in wavelength. And red shift means always the wavelength is stretching. When the wavelength is stretching, at the same time frequency is decreasing. And there is no way wavelength of electromagnetic radiation in the emission spectrum of the astronomical object. Blue shift, any decrease in wavelength. When the wavelength is decreased, and then naturally the frequency is increasing. It's exactly when you compare the radio waves, we have long wavelength, but at the same time frequency is less. But when you go all the way to X-ray gamma rays, and then you can say the wavelength is so shrinking, but at the same time frequency is increasing. There is no doubt always the proportionality in laws of physics is always observed. And this is the explanation that, always the wavelength, stretching wavelength is proportional to shrinking wavelength. It doesn't matter how much you stretch it, at the same time you're going to squeeze the other side. This is amazing photo of stars. And probably most of you have seen. So you don't even have to be an astronomer because most people, like when I was 6 years old, 7 years old, I remember I used to stargazing. And this was my favorite. It's called Seven Sisters. And then the name is Ursa Major, or they call it the Great Bear. And I remember, not this one. This is the present one. We are always say these are so distinct. And then at that time, I asked so many physics teachers, science teacher, they had no idea. When I came to United States, I print this from the physics book, and then I realized this star is 108 light years away. Can you imagine? And this one is in the same plane we can see at night when we watch the sky, 62 light year, 108 years, and this one is 75 light year. But you can see they're all in the same plane. You cannot distinguish which one is farther, which one is closer. Well, let me give you an example. The light travels 300,000 kilometers per second. So in other words, one light year is 5.88 trillion miles, or 9.46 trillion kilometers. And imagine if some stars are 2 light years away, so they're 20 trillion kilometers away from us. And some of them closer we can find to humans, for the our Earth, which is 4 light year, which is 40 trillion kilometers away. And you can see, like those all you can see in one plane, but this is 100 years ago, and I don't know how they did this. And imagine they just took a picture and then see how different they are now. And then another 100,000 years, we're not going to be alive, it's going to be much different. So you can see how difficult it is to, conceptualize or visualize how far the, stars are. This is another important part. And imagine when we're talking about, application, Doppler is used in every aspect in our life. It's so important in our life. But let me tell you one by one. The first one is robotic dynamics. You know what? We have factories, car factories, manufacturing like a food industry, beverage, millions of factories. So nowadays the humans are not as good as robots. If you go to Tesla factory, you can see everything is done with robots. It's much cheaper, much better, and the precision is 100%. But the humans are not as good as robots because they're strong. The precision is by, according laws of physics, and then your electronic is ordering to mechanic what to do, but the humans can't do it. So imagine the robotic, how they do it. Everything, if you program, and then if everything works fine, the precision will be 99.9%. But the humans, we can't do it. And the next one is like sirens. I just explained a few minutes ago, for the sirens, when it's coming close to you, the waves are, like bunch up, or in other words, they just shrink, and then when they go away from you, they are stretching. But imagine what if you are the ambulance driver? You won't feel that experiment. You don't feel that, the wave is, because you are the source, and you are going with the source. When you are the driver of the ambulance, you cannot feel it. But if I'm standing in a street and the ambulance is passing by, I can feel it because I'm stationary. Well, of course, you have to go back to Galilean relativity, and then you can see one object is moving and the other object is stationary. So you have the frame of reference, because frame of reference in physics is extremely important. And the next one is astronomy. Like I said, redshift and blue shift. And like I said, they can tell which star or which galaxies or which nebulas are moving away, and then they can determine, because the precision is beyond my imagination how good they are. And the most important one is the radar. And imagine a World War, the airplanes would go low flow, and then, in a valley, so they won't be detected, because radar means radio detection and ranging. But nowadays it's so different, they can fly high because the technology is so good nowadays. But, radar can measure the velocity. If you're, speeding in the street, cops can stop you. Those are small, low range, so they can tell you that, you're speeding 60 kilometers or 100 kilometers, so they can stop you. Because everything is going back and coming to you, going back and coming to your camera. And then, in fact, a month ago, I explained about the bat, it's ecosystem. Eco location, not ecosystem. So bat is amazing. So they are doing the same concept. It doesn't have to be electromagnetic or sound, but it's the same thing. But something happened. Here, radar now is so different, because Doppler effect can be used in so many things. Medical equipment, they can use it for the blood flow. But this is the important part, for the satellites. I remember when I was watching a World Cup, that was a long time ago, 1966, when I watched the England versus Germany. We were so happy. We were dreaming about that a month, and finally there was a, millionaire. His house was so big. We had to watch it in black and white. So I watched Germany versus England, and England won 4-2, and it was live. It was amazing. We were watching black and white. And at that time, I was 16 years old. I had no idea. Nowadays, we can watch everything. Now I watch the Euro these days, and I watch Copa America, everything else. Everything is so clear, so nice. Everything is satellite. A satellite changed our life. And imagine we have 27 satellite orbiting the Earth. 90 minutes they go around the Earth. That's how fast they're traveling. And they can get us all the information, everything. But unfortunately here, something comes in equation. His name is Albert Einstein. And then his general relativity predicted that, well, of course it is true because it's proven fact now that if you travel much faster and then you come back to Earth, you are not going to age that much. Well, of course, it's not a big deal. I mean, we're talking about fraction of a millisecond. So satellites are going around the Earth, on the Earth orbit. But you know what? Their speed is amazing. It's not like us, the way we're traveling, like 60 miles, 40 miles. They're going so fast. So what happened? There is an offset here. So their timing is not going to be exactly the way we time it on the Earth. Because this was proven fact. Some astronauts, they stayed in space like 6 months, and some of them, I remember the Russian, he stayed 8 months. When they come back, there was a, atomic clock inside the International Space Station. There was another one set on the Earth. When they came back, that astronomer was, few milliseconds younger. Well, that few milliseconds makes a big difference. So it tells you that the general relativity prediction was right. If you can go speed of light, you will not even age. So, well, of course, it's beyond our imagination. That's not going to happen. But the main concept is the faster you go, the slower the clock goes. So, in other words, you are not going to age that much. And this is what happened. And the Doppler effect is getting that offset and adjusting that so they won't die. And then the next one is meteorology or weather, and they can predict, when the storm is moving in, when we have a high pressure, when we have a low pressure, and the most important part is the hurricane. And imagine if they can predict this half an hour, even 2 hours, or 1 day ahead of time, the damage will be millions of dollars less. People can escape, they can, save their life, and also they can save their animals and everything else, and also they can save money by just moving away, so will be less damage. So that's what the Doppler does. And imagine how important. Next time you hear that the meteorologist is talking about the Doppler effect, because they check the Doppler radar, and they know exactly what is moving in, what is moving out. So you see how important it is. And like I said, from now on, I decided to do every 2 weeks, and I'm hoping, you guys would love it. And then I received so many emails, people complimented me, and then I want to thank that, that is great rewarding for me, that your encouragement makes me to make more videos. And my main objective is to activate your sense of wonder, especially the young generation. So my main objective is to promote the science. So I hope you like this video. If you like this video, you can go ahead and subscribe it. And next time I'm hoping it's going to be laser or electromagnetic wave or color perception, or it's going to be optical fibers, either one of those. So I will publish it in 2 weeks. Thanks a lot for watching, and appreciate it.